Hi students, today I am going to explain what is gas chromatography. So gas chromatography is also a physical process in which a gas mixture is separated into its constituent particles by moving gas phase over a stationary absorbent phase. Same, all the chromatographies are same. Here in gas chromatography, we will separate two different gas mixtures. So this gas chromatography is again classified into two types. One is gas solid chromatography, GSC, gas liquid chromatography, GLC. So in gas solid chromatography, we use the active solid absorbent like granular silica, aluminium or carbon. But in a gas liquid chromatography, we use a thin layer of non-volatile liquid coated on a solid. So we can see here what is this process. This process involves observation of gases on solid surface and is chiefly applied to the separation of permanent gases and low boiling hydrocarbons. So this gas chromatography we use to separate the gases by absorbing a gases on a solid surface or on a volatile liquid, so that we can separate some permanent gases or some low boiling hydrocarbons. So what is the principle behind it? We see when a gas comes in contact with the adsorbent, certain amount of it gets adsorbed on solid surface. So when a gas comes into that adsorbent surface, some gas will get absorbed on the solid surface, so that it will be separated. So it is according to the Freundlich's law. So x by m is equal to kc to the power of 1 by n, or x by m is equal to k1c plus k2c. So this is the formula. So what is x? So mass of the gas, and m is mass of the adsorbent, and k is a constant. We know k, k1, k2 all are constants, and c is the vapor concentration. So how much vapor concentration and the mass of the gas we are blowing on a solid surface, or mass of the adsorbent, so that how much it is absorbing. So like this we do. So what is the experimental technique we use here? So it contains a carrier gas supplier. So the gas we take must be chemically inert, because if it may react with other gases, so that will not get the correct value. So the inert gas should be taken. So more commonly helium, the first inert gas we take, even though other gases like hydrogen, nitrogen, carbon dioxide, argon are also used, but helium we prefer more, and these are available in pressurized cylinder. So the gas is available in a cylinder which is pressurized, and the choice of the gas also depends upon what is the nature of the sample we are using, type of the detector we are using, column efficiency, availability, purity required, and also the consumption rate. So depending upon all these factors, so we choose the gas. Next we will see this is a pure gas cylinder, pure carrier gas in the cylinder which is compressed in it. So it contains a flow regulator to control the flow of the gas, and also a control pressure will be there. So then this gas will be allowed to flow into the sample. So this is a sample injection system. So amount of the sample which we want to take depends upon the nature and concentration of the solute. So whatever is the solute we are taking, depending upon that, and the size of the column we are using, and the sensitivity of the detector. So whatever is the detector we are using, how much at what range it will detect. So it's a sensitivity. The usually range we take is 0.1 to 0.50 microliters for gases and liquids, whereas for solids only a fraction of milligrams we take sample to separate that. And the device used for liquid and gas samples are micro syringe. We use micro syringe to apply the sample, or for solids we use glass and ampoule, and even valve also we can use for gases. Then chromatographic column, thermostated column, here it is Yes, no, this is sample injection. Here we will inject the sample with the help of some micro syringe or valve or some glass and compel. So, and here it is the column, thermostated column, means temperature is maintained in this column. It is made up of materials like stainless steel, copper, glass or plastic. So, this column is made up of that materials, and it may be coiled. So, it is coiled like W shaped or U shaped to permit convenient thermosetting in an oven. For most of the analysis, the columns are at 120 centimeter to 5 centimeters length or 2 millimeters to 10 millimeters diameter we will use, and the column is packed within an inert support material or large surface area such as diatomaceous earth. So this column is fixed in an inert material to avoid other gases or something to react with it, and also we provide large surface area, that's why it is coiled. Then next is column thermosetting. I already told it is thermostated column. So to obtain good separation and good chromatography peaks, shapes, so temperature in the column is to be controlled within a few tenths of a degree, and the temperature depends upon the boiling point of the sample. Whatever is the sample we are taking, we should set the temperature according to the boiling point of it. Then next is detector. The detector senses the arrival of separated components of the sample present in the carrier gas by providing electrical signal. So this detector will give some signal so that the components are separated, and the most widely used detectors are thermal conductivity detectors and flame ionization detector. Then a recorder is there next. So recorder, so it gives rise to small and then detector. So it will sense the arrival of separated components of the sample present in the carrier gas by providing electrical signal. So it will give the electrical signal so that it will sense or give the separator of the components by giving some signal. So my most widely used detectors are thermal conductor detectors and flame ionization recorders. Next, recorder. So it will give rise to small and weak electrical signals. So it is therefore necessary to pass the signal through an amplifier, as it will give very weak signals. So we cannot know that. So it is connected to an amplifier to make it more. So before feeding into the recorder, it is the signals will pass through an amplifier. It consists of two parts. A mobile pre-recording pen will be there, activated by a signal, and a recording chart strip will be there. So it will give the value of our chromatography. So how this happens, how the instrument we have to use. First, the carrier gas obtained from a steel gas cylinder passes through a flow regulator from the adjustment of flow rate and enters into the sample injector. A little amount of sample is introduced into the sample injector with a syringe, hypodermic syringe. Then the temperature is raised or setted according to the boiling point of the solute. Maintained at high temperature because of the boiling point of the highest of boiling points of sample, in order to ensure rapid vaporization of the liquid samples. So why we will take according to the boiling point of the components of a mixture? Because at that boiling point only it will get vaporized instantly, that liquid sample. Then the components of sample are distributed between the stationary and mobile phase and passed down column at different rates. So this results in the separation. Then it will enter into the detector, which change in the composition of the carrier gas. So this is amplified before it fed into the recorder, which drives the recording pen on a moving strip of paper, and chromatogram is obtained. So like this we'll get a chromatogram. So a very easy process. So the gas under the control of flow regulator, it will go into the sample. So here the thermostated column will be there. So here when we pass into that above the boiling point, it will vaporize and the chromatography will takes place, and it will be detected by a detector, and a weak signals will be passed into the amplifier because before it is sending into the recorder, which is connected to a pen, recording pen, with a signal and also with a chart strip, so that it will give a chromatography. So it is a very easy process, and we will get the chromatography peaks like this. So we can see, and this one is W1 and this one is W2. So this one is retention time or volume of the carrier gas, retention 2 or volume of the carrier gas 2. So like this we will get the peaks, and VR is equal to TR FC, where VR is the volume of the carrier gas is equal to retention time into flow rate. So VR is equal to V dash R is equal to VR minus V air. So TRFC minus TA FC. So then what are these applications of gas chromatography where we can use? So we can separate a benzene and cyclohexane because they have very nearby boiling point. See here, benzene have boiling point 353.1 K, whereas cyclohexane have 353.8. So boiling points are very near. In other techniques it is very difficult to separate, but in the gas chromatography we can easily separate a benzene and cyclohexane, and even the separation of so many hundreds of petroleum hydrocarbons also very easy with this. And it is also used to separate like hydrogen, carbon dioxide, carbon, oxygen, methane, so many mixture of gases to separate easily. And also it is also used in volatile substances and automobile exhaust gases to analyze what are the gases present in that and separate it we can use. So like this, gas chromatography is a very important and useful technique to separate the mixture of gases. Thank you.